Hello, this is David Birch at Star Path School of Navigation in Seattle, Washington, with a video illustration, actually the first one of a series of a few here. This is a discussion of the OpenCPN CellNav plugin, and so I want to illustrate that, and it has some very nice features. But we want to just start out first with just the basics, and then add on more of the analysis later on. And so we're going to be looking at we're going to use real data for the analysis. This is the last voyage that I actually did by Pure Celestial Navigation, 1982. We're going to be looking at some fixes right in this area here on July the 8th. So that's the voyage there. Let me get rid of that, and then later I'm going to come back and show you we have a book published where you have all these practice problems and the things are all laid out so you can look at it. So we're going to look here. Here's the actual DR track plot of that leg. Here's on the dates that we're looking at on the 8th. So we're looking at a series of running fixes of the sun between this 10:09 and 13:07 local time, Pacific Daylight Time, and then the fix that was done that shows that the DR was quite a bit off to the west. And here's the fix that we're going to get to, or we're just going to approximate it with this first pass. So that's that. That's the site we're doing there. And then looking ahead to maybe the next video or some where we'll do all of them. Here's the series of sites that was actually taken during that voyage for that day to navigate with. And there were 3 sun lines in the morning, 10 o'clock watch time, local Pacific Daylight Time, and then 3 more sites in the afternoon. So this is like 1300, it's 10 o'clock. Notice you could take sites, and in the real world, this is true, after you do it for a while, you see that you can take a site and reset the section to be, perfectly random and do it again about once a minute. So these sites you'll see 9, 11, 12, and then 3, 4, 7. So it's once a minute. Now to start out with this first one, we're just going to do 2 sites. In reality, you always want to do multiple sites. 3 is a minimum, really should do 4. It's better of each body. But right now we're going to just do 1. We're going to take this first site of this morning session and maybe, I guess, the first site of this afternoon session, like that. And so those are the 2 sites we're going to analyze for a running fix. That is that. Now those are pulled out here. Now to do a fix with celestial navigation, you have to, actually a unique thing about this program is you don't really need a DR position. You frankly don't need a DR position, but you need to know your course and speed during the site session. So in normal, and what I might call normal celestial navigation, the way we teach it in textbooks and things like that, we use an assumed position and tables and so forth. But with this program, you actually don't need a DR, assumed position at all. However, we do have to know our course and speed at all times during the celestial navigation. That you cannot do away with. And in reality, you're going to know your DR. You're going to always know your DR at the time of the site. So in this particular case, we have the DR position at the first site and the DR position of the second site. And so then that's the first thing we have to do. We have to get those into the program. And as we see here, the celestial part of these type of ocean navigation, that's a really easy part. Easy, fast, accurate. What is all this peripheral stuff that takes time? So let's go, and we got to plot these 2 positions. So I put one of them in already just to save time. So I'll go up here to the waypoints and now say new, and I'm going to put, what is this other one? This is going to be the DR at 2003Z. So this is going to be called DR at 2003Z. The Z reminds us that it's a Greenwich Mean Time, Zulu. And what's that position? 3905. 39, and this works real well in OpenCPN. You just put 39 space 05. That's good enough. No symbols or anything like that, or decimals. And, we don't have decimals here, but 39 where was it? 39.05 even. And then this is 131.36. So this is now 131 space 36.0. Okay, and that's that. That's everything okay. So there we've got our two DR positions. Now again, we don't need those, but what we are going to need, let me take an M key. I'm pressing the M key now. Am I? Yeah, no, what key am I pressing here? Cancel. Cancel that. Well, what's all that doing here? Okay, I just want to measure this. Let me just close this for the time being, say that's okay. I'm just using the M key. I want to measure, there you go. I want to measure this because this is what we need to know, how far we move between sites. And it looks like it's about 19.3 at direction 169. That's what we need to know. All right, so let's do the celestial. So now here's the plug-in. Here's the plug-in. But actually, let me back up. That is the plug-in. And but here's the first thing you want to, when you download the plugin, you want to go and get the latest, be sure you have the latest version of the plugin. So here's I click the wrench, then the plugins, then you look here, Celestial Navigation 2.3. That's the latest version. I'm on a PC. Up until yesterday, the latest on the Mac was 2.0. But now the Mac is also 2.3. So you want to be sure if you got a Mac version or a PC version, you want to download the latest version. That should be 2.3. And that's okay. So that's good to go. Now we do the Celestial. Oops, that's not Celestial. Sorry. That is something else. Okay, here's the Celestial. Oh, and I've got these sites in here. Let me just okay, I'm going to take them. I'm going to delete it. Okay, so here's how you enter a site. Well, I'm going to delete it. So you come in here, it's totally blank. So then you say new, right? Say new, and what is the site? Here's now your choice is the type of site. You get altitude, azimuth, and lunar. Well, this is again. So there's special features built into this program that don't appear in all CellNav programs, but the regular celestial navigation site reduction from the height of a section. Section height measurement is altitude measurement. And we use that altitude measurement at a given time, and we're going to get a line of position. In fact, in this program, you get something more sophisticated than a line of position. You get an actual circle of position, which is technically the correct way to do it. You draw a circle of equal altitude on the surface of the Earth and then intersect those circles. And that's the way this program mathematically solves this problem, which is correct, the correct method. So that's what that is. But now then azimuth is another way in principle, I don't know what this is here. Definitely not magnetic azimuth. Azimuth, in principle, you can get a fix from the bearing to an object, plus its height. And I'll come back later. That's not uncommon. What's this going on? I'll come back later and do an illustration of this. It's not a standard working tool. It's something that exists in principle, and I'll show you later that you could do this. You could just actually take with a gyro compass or some really accurate bearing with a gyro compass to sunset. Just then the lower limb touches the horizon, you measure that accurate gyro bearing, and HS lower limb 0. And then you could get a fix like that. There's not a fix. Well, actually a fix. Excuse me. I take it back. That's what this is, a fix. Normally you just get an LOP. But let's come back to this. The other thing is lunar. And so this, and I haven't worked this out yet, but this will compute lunar distances. And then I look forward to making an example of that and checking it with several other ways to check it. But this is a way you could measure the distance between the moon, one edge of the moon and a star, or one edge of the sun, and from that data determine the GMT, the correct GMT. So in other words, you can find your longitude if you lost your watch, lost your clock. And that's a very interesting and powerful function of this program. I have not tested that, and that's not the subject now. So now we're going back to just plain old, I've got the height of a sun. I'm going to do a running fix from 2 sun sites. And in these cases, we did the lower limb. I didn't say that. Oh, yeah, it said that, back here. Your logbook has to always say what it is. That's lower limb. And now, okay, so now we're ready to go. So what do we have for our sites? Let me look at this. This is the measurement now. So the measurement, I'm going to do the first one here first. That was 1709. That's 40 degrees, 35.5. So this here is 40 degrees, 35.5. I'm entering. This is HS. Now, this has a default to minutes of uncertainty of 10. That's frankly way too big, and that's the default. Let's say 1. I'd like to say 0 or 0.5 or 0.2 or something, but it won't run very well if it's less than 1. And I'll come back. Let me come back to that and discuss it later. For now, just put this 1. 1 is a realistic number. That's 1 arc minute. In other words, when I say 35.5 minutes on my sextant, then that means I'm confident that it's not 34.5, 36.5. Now, in practice, with real celestial navigation, you can do really notably better than 1 minute and be totally confident in it. But let's come back to that later. But for now, just put this equal to 1. It really won't matter for what we're doing. And then we take the time. Now, the time, we're going back to 1982 here. And it's July 8th, 1982. So this is really set up in a slick way. I click this number up here, then it goes to the different months. Then I can click it again, then it's going to different years. Then I can click it again, it's going to different eons or something. But I have to go way back into eons to 1980. And then I go to 1982, and I'm going to July. And then July 8th, I think it was July 8th. Yeah, July 8th. And the time, and this is Greenwich Mean Time, or UTC, 1709:35. So this is 1709:35. And uncertainty, now this defaults to something, or I don't know, maybe that's 0. Let's leave that 0 for now. Again, that has, real numbers, but 0 is fine. In other words, in principle, I can time this to a second, but it's, half a second or, something like that. But it all depends. I mean, you may have something where you have to claim it's a little worse. But okay, so that's that site. Okay, we got it. So there's the first site. That's that. And see, what it did then is it looked up in the almanac. See, if I go here, I'm just discussing this, and later we'll come back with some more real navigation where we won't just spend so much time discussing things and get right to it. But if you go to the calculations, so what this did was first thing it did, you gave it a time and a body and a time and date. It looked up the geographical position. That's a GP. That's a declination in the GHA. And it plotted a point there, and on the circle of a surface of the sphere of the Earth, it drew a circle centered at that point, called the circle of equal altitude. And your vessel is somewhere on that circle. That's the way celestial navigation works. So what this means here is if I zoom out, that one site of the sun, here's I don't know where it's marked. That's actually the boat position from some other thing else. I'd have to figure out how we show this, how we show the GP. But right now it's centered over here on the right somewhere. But this is everywhere on this circle at that time. At this time here, what was that time? 1709:35. Everybody located on the Earth that's on this circle at 1705 would have measured exactly the same height of the sun. Now, and here he converts that to decimals. I'll write a note someday here and ask that it'd be nicer if once we get a whole bunch of sites here, it's a lot nicer if this were in degrees and minutes. Here it's converted to decimals, but that's here's the one we typed in, 40 degrees, 35.5. That's a little over 30, and you see here, a little over 50.5. That's about right. Okay, so now we have a new one. So I could add new. But then I have to go get all the data again, like figure out the time and everything. For many of the sites, like if we're doing a series of sun lines, it's better just duplicate this because they're going to be all pretty similar. So I just duplicate this one. And now that's 1709. And now what's my next site? It's 2003. So I've got to go in here, open that one. And again, it's an altitude, it's a sun. And now the height of this guy, let me come back here, he's 70 degrees 35 minutes. See, notice quite a bit higher. It's afternoon now. See, before it was mid-morning, it was a lower sun. Now we're in the afternoon, and it's 70 degrees 35. And then again, we'll call that 1. And now we go to the time. And the time in the afternoon here was 20:03:32. So this is 20:03:32, and okay. Bang. So now it's gone in here, and it's done a couple things. First of all, it plotted the second circle of position, and then it computed a fix. And I'm going to have to come back to that fix, because this is not the right fix. Obviously, it's not right, because these two sites were taken 3 hours apart. So that's not the right fix. But the way we fix that is we know, and he's got the fellow that wrote the program here has got this a way to fix this, or it's designed to, I guess, function that way. And so what we do is we have to know this distance between here and here, between these two. So hit the M key and go from the center of this guy to the center of this guy, and that is 19.4 in direction 170. Okay, so we have to turn this into a running fix. So what you do is you just click this one, and this is what this button is for, DR shift. So we want to shift we want to move the first one, 19.4, in direction of 170. 170, and it's definitely true bearing, not magnetic, true, and say okay. Let's do something different. Let me go back. DR shift, and we go 0. 0, 0, okay. Back here. Now, I'm going to go in here. I just want to show the effect of this. You know, the effect could be big or the effect could be not big. It depends on the angles. But let's go in here and drop a mark right here. Drop a mark right there. And then I'm going to go right-click that and get the properties. And I'm going to put a mark there, and I'm going to call it fix. Fix. Well, just say fix. Fix with no advance. No advance. Fix with no advanced. Okay. So in other words, I know that's not right, but so that's as if we were dead in the water when we took both sides. And we're not dead in the water. So now I can go back here to this guy and go to the DR shift, and now and that is 19.4, and then 170. 170. That's true. Okay, bang. Okay. So now, what did I do? Oh, I shut these guys off. Okay. I just have to move this aside without shutting it off. Okay. Now you see. Let me zoom out here. Here's our actual fix right here. So you can just drop a point here, drop a mark, and then give a right click that one, properties. This is a fix, FIX, fix 2003 Zulu. Okay, so that's what we're after, a fix. Right there. And then this doesn't mean anything, it's just wrong. So you can go in here and just delete that guy. So there is now that is the very basic use of the program. That's a very basic use of the program. And then what you would do from here then, you see your DR is wrong. Your DR is wrong here. Now, one of the things we always encourage people to do is you have to keep a logbook, and it's very important to record this distance right here. In other words, you were 29.9 miles off. Your DR was wrong, 29.9 miles in the direction 094. This is a way we study and learn about currents. We learn about any kind of systematic errors, one thing or another. So that data right there has to be stored. So you don't just randomly go forward here. You write down this latitude and longitude in your logbook, and then you also write down that your DR had to be shifted about 30 miles to the 094. And then you're ready to just draw a new line right out of here in your new DR, the new DR direction you're going. So that's the way the plugin works. There's a lot more to talk about it, but with these background points out of the way, we can now get into the more sophisticated applications, because in reality there's like 4 or 5 sites there. Instead of you would never do one sunline. That would be you defeat all the purposes of CellNav to take just one sunline. So you take 4 or 5 in a row, put the sextant away, come out in 3 or 4 hours, take another 4 or 5 in a row. Then you do the fix. And this program will handle that very nicely, but you have to do that little DR offset for every single site. And then, so I'll illustrate that and some of the other unique features of the program. This program would be very nice when you're sailing underneath, when you have to deal with very high sites. Okay, that's the end of the talk.